The basic law governing the working principle of transformers are Ampere's law and Faraday's law of electromagnetic induction. Ampere's law is that supposing this pen as a conductor, and if a current is flowing through the conductor, a magnetic field will be created around this conductor, and Faraday's law of electromagnetic induction is that whenever there is a relative motion or change in field of magnetic field and a conductor, an EMF will be induced. So the principle of transformer is this is a primary winding, and similarly there will be a secondary winding. If a current flows through winding, a magnetic field will be induced here around this conductor. This magnetic field is conveyed to other parts through this magnetic core. This comes at the secondary of the secondary of the coil, and this varying magnetic field due to this changing AC magnetic field will induce current in the secondary winding of the transformer, or induce EMF in the secondary winding of the transformer. So the basic law governing the relationship between electric current and magnetic field is Ampere's law, which states that surface integral of JdA is equal to line integral of closed circuit of HDL, where J is current density in amperes per meter square. However, this is very large quantity. Practically, amperes per millimeter square is considered, but SI unit is amperes per meter square. H is magnetic field intensity in ampere turns per meter. Means if this length is 1 meter, so how much ampere turns is present in this 1 meter length? This is ampere turns per meter. This equation states that the line integral of H around a surface through which the current density J passes is equal to total current enclosed. So left hand side is automatically converted to Ni, where N is number of turns, I is current, and right hand side is converted into HCLC, where HC is magnetic field intensity in the core and LC is mean path of the core. The ampere turns Ni can be produced by one winding or more than one, where the total of all windings is Ni. This ampere turns can be produced by one winding or more than one winding. Okay, so magnetic field intensity H produces a magnetic field density of B everywhere. This magnetic field intensity H produces a magnetic flux density B, where it exists of value B is equal to mu H. B is equal to mu H, where mu is permeability of free space. The unit of B is in Weber, and 1 Weber is equal to 10 to the power 8 lines of magnetic forces. In SI units, the permeability of free space is 4 pi into 10 to the power minus 7. Permeability of free space is equal to 4 pi into 10 to the power 7 Webers per ampere turn, where Weber is the unit of magnetic field intensity. The permeability of ferromagnetic material is usually expressed as relative permeability mu r. So for ferromagnetic material, permeability is written as mu 0 into mu r. So this is relative to mu 0, that means free space. Mu r is in the range of 2000 to 6000. So permeability of magnetic material is 2000 to 6000 times that of free space. The value of H along the paths are independent of whether they cross the materials or free space. This value of H is independent of this is there is continuity of core material. So, but the value of magnetic field intensity is independent of whether it passes through the core or this gap, that means free space. However, the flux density B produced by the H is negligibly small everywhere except in iron core. Flux density B around this air gap or in the surrounding of the coil is negligibly small. When magnetic circuits are analyzed to determine the flux and flux density in the main magnetic path through the core, the magnetic field outside the core and its gap is usually neglected. So, magnetic field is neglected outside the core usually, but in analyzing the transformer or electric rotating machine, the field outside the core, that is called leakage fields, are extremely important in determining the coupling between winding. Here this is primary winding, here will be a secondary winding, there will be magnetic coupling between these two windings, and due to Faraday's law of electromagnetic induction, a varying magnetic field will be created by virtue of an alternating field. This varying magnetic field will create this varying electric source, AC source will create a magnetic field. This magnetic field will come down here and induce EMF in the coil wound in this circuit. This is the principle of transformer. That's all in this video. You may like to comment, share and subscribe the video. Thank you very much.